Good afternoon and welcome. Last year, when the annual meeting was canceled, one of the things I was most disappointed about was that we would miss Professor Steve Raudenbush deliver the 2020 Hedges Lecture. To me, the Hedges Lecture is one of the highlights of the annual conference, as it always leads to thought-provoking conversations and reflections about our role as researchers. So when it was announced that we would be going forward with a virtual conference this year and that Steve would be giving the Hedges Lecture, I was thrilled that all of us in the SRE community would have the opportunity to listen and learn from Steve. For those who may not be familiar with the Hedges Lecture, it is an annual award that has been presented by SRE since 2016. The lecture is named for Larry Hedges to honor his work developing statistical methods, advocating for the improved rigor of education and social science research, and providing foundational leadership to SRE. The award is meant to provide an outlet for us as a SRE community to honor the central role that methodological development and advocacy for scientific rigor play in improving education research. After listening to the description of the award, I'm sure it will come as no surprise to most of you that Steve would be selected to deliver the Hedges Lecture. Steve is the Lewis Sebring Distinguished Service Professor and the Chairman of the Committee on Education at the University of Chicago. He is best known for his statistical contributions to the field, most notably his work developing hierarchical linear models. His HLM textbook has been cited over 28,000 times and is used to train graduate students across the world. Steve's list of accomplishments and awards is long and include being a member of the National Academy of Education, the National Academy of Sciences, and a fellow of the American Academy of Arts and Sciences. Although Steve is best known for his statistical contributions, I want to share what I believe are equally, if not more important, contributions he has made to the field of education research. Across Steve's work, a clear theme emerges around the use of rigorous methods to better understand students, teachers, and schools in order to reduce inequality in education. From papers such as Does Schooling Increase or Reduce Social Inequality in the Annual Review of Sociology, to a recent book he co-authored entitled The Ambitious Elementary School, Its Conception, Design, and Contribution to Educational Equality. Steve's commitment to social justice and reducing educational inequality is central to his work and who he is as a researcher and as a person. As a former student of Steve's, I have witnessed his passion and commitment on numerous occasions. One of my favorite memories goes back to the AERA conference in 2006 in San Francisco. It was one of my first AERAs, and I remember being really nervous about how to select what session to attend. After the first day, Steve was hosting a dinner for his graduate students. When I got there, I was talking to him and asked him what sessions he had attended that day, still second-guessing my own choices.
He told me that actually he didn't attend any sessions. There was a social justice march going on in the city, and when he left his hotel that morning, he couldn't resist joining in, so he spent the day marching through San Francisco. As a methodologist in training, this was an important moment for me to step back and reflect on the bigger picture that drives the work we do. Steve's steadfast commitment to the use of rigorous designs and cutting-edge statistical methods to produce strong evidence to drive change in schools and reduce educational inequality will be on display in his talk today. I am excited to hear his life course perspective, and I look forward to how it can help guide us in the future. And with that, I will turn it over to Steve.
Well, thanks so much, Jessica. It's a very generous introduction. And of course, it's always been such a joy to work with you on issues related to experiments in education. And, you know, Jessica is a historian, really, of IES and SRE. Larry has made a transformative contribution. I would say transforming a specific technique for summarizing evidence into really a way of thinking about everything we do. And it's actually connected with the work that Jessica is doing, because what we want is to accumulate evidence systematically and to do replication studies. And for that, meta-analysis is really the paradigm, as Larry has developed it and popularized it for us to, how do we think about that process? Now, that said, I have to admit, it's a little alarming to be giving a talk named after somebody who's younger than I am. But Larry is a little more senior in his career. After 2 years in the Army and 9 years as a practitioner, and I use the word practitioner loosely, I'm not going to tell you everything I did during those 9 years. I went to graduate school. And so I started off later in my career, a couple of years after Larry had started his, and that's when I encountered his work. When I was in graduate school, I was really interested in the controversy about teacher expectancy effects and how do we summarize the evidence. And since that time, since I started at Michigan State in 1984, I've had many occasions to work closely with Larry on the Journal of Educational Statistics. Larry spent a year at Michigan State. And then sometimes, we really weren't interacting much. But I always have felt that whenever I was thinking about what I was trying to accomplish, and even though Larry and I might not have been interacting, that we really had a common project. Advancing education statistics, which was really a major goal of Larry's late advisor, Ingram Olkin, and improving educational science. So it's in that same spirit that I'm hoping to speak today. I do want to say that I want to dedicate today's talk to another remarkable researcher and a wonderful colleague, but one whom we tragically lost last year, Carol McDonald Connor. And I know many of you know Carol. And Carol, in her career, made many contributions. By the way, Carol was a practitioner for years, speech and hearing pathologist, working in school settings, trying to help kids who were hard of hearing or had other kinds of difficulties before she became a researcher. And her knowledge as a practitioner had a lot to do with her work as a researcher. She began studying cochlear implants and children's language development. She studied how to improve education for hearing impaired students. She studied how to teach kids who vary in their dialect. She also studied she studied the joint effects of emotion regulation and academic learning. It's not looking at these as sort of separate domains, cognitive, non-cognitive, but integrating those, seeing how the developing child really masters those things together. But what I want to focus on today, let's see if I can get this thing to work, is Carol's many studies showing how we can use assessments of children's skills and tailor instruction to the heterogeneity of skills that kids bring with them into the classroom. And much of this work has been joint with Fred Morrison. I don't know if Fred is out there, but Fred deserves also a great deal of credit for what I think is absolutely foundational work, and it's tremendously influenced the way I think about schooling, and it's going to be very much motivating the talk I'm going to give. I'm going to use this term, fancy term, maybe pretentious, dynamic instructional regime. And that's going to be what I'm going to focus on today. Here's just I'm not going to go through all these, but I'll make my slides available. You can see, these are many of the really foundational papers that Carol and often with Fred published. And in the spirit of IES, using large-scale cluster randomized trials to really test out this idea. Kids are heterogeneous. We can assess them. We can tailor instruction. We can dynamically push them ahead, reassess, that sort of idea. But to frame this, by way of background, I want to talk about two seminal events in the history of education. The first being the Elementary and Secondary Education Act, 1965, Title I, which you're all familiar with. And the second one, I guess, which this crowd is all familiar with, not everybody in the United States is, the Education Sciences Reform Act of 2002, the founding of IES, and then shortly thereafter, the founding of this organization, the Society for Research on Educational Effectiveness. So as part of the push for overcoming inequality, the push for civil rights, the anti-poverty movement, Title I established what became the key federal priority for many years. And this quote by Lyndon Johnson, "Poverty must not be a bar to learning, and learning must offer an escape from poverty." This really captures the spirit behind Title I. And in its various renditions, that idea has always been the goal. And it's been largely bipartisan. People will disagree dramatically over how we should organize schooling better to make things more equal. But whether whether you believe in public schools should be, that's where the resources should go, increase the resources, support teachers, and whether you also believe in school choice or charter schools, the logic of the argument is around how to reduce inequality. Okay, what's the best way? And so I say that through Title I, equality of opportunity has driven policy from 1965 until 2016. I don't know, I'm not sure quite what happened after 2016, but we'll find out what's going to happen in the next rendition. So the problem is that when we look back over this long period of time, we see that while black-white inequality has reduced dramatically over the whole more than a century, and I'm referring to Derek Neal, my colleague at Chicago, has a wonderful handbook chapter on this, but black-white inequality remains large, and recent research, some of it pioneered by Sean Reardon, would indicate that income inequality, social inequality, and educational outcomes has actually increased during the same time. So we've, on the one hand, right, we've got this federal push, which is dedicated to reducing gaps. On the other hand, we have these gaps increasing, or at least being stable. And I don't mean to imply that Title I has not had an effect, because we don't know how bad things would be without it, right? That's the counterfactual. And we know that our society has that income inequality, just not in education, but literally family income and wealth inequality, have dramatically increased since 1965. So it's not surprising in some ways then that educational inequality would also increase. But what we can say is that the Title I hasn't been enough to dramatically overcome inequality. And the question is, how do we think about that now? And the second seminal event that I'm referring to, the founding of IES, oops, get this thing going here. Oops, there we go. Has helped us establish a rigorous basis for studying causal effects, and in my view, that's absolutely fundamental. I mean, we wouldn't imagine trying to solve the problem of having a massively available vaccine for COVID without clinical trials. And so it was really as a result of the founding of IES that we started not just doing randomized trials. People say it was the whole purpose was to make everybody do a randomized trial. I would say a little bit more broadly to help people, to encourage people to think rigorously about causal effects of new interventions. Randomized trial being a crucial tool, although many natural experiments are also very important in helping us do this work, and we don't necessarily have randomization. But with that in mind, I also want to think about, well, what's missing? And what I would say what's missing is that, knowing what works, which is really the sort of watchword, the goal of IES, is necessary but not sufficient to substantially reduce inequality. And the reason I say that is that inequality, racial inequality, social inequality, income inequality, in educational outcomes are overdetermined, by which I mean they have their source in multiple contexts of a child's life, right? In the neighborhood, in the family, in the school. in inequality in those domains of a child's life. And they're cumulative. So just as, one of the things about opportunity, right, that is wonderful, is that opportunity creates the chance for more opportunity. Good things happen, you learn more, and you get a chance to go farther in school. You go farther in school, you get a chance to learn more and maybe go even farther. You get a chance to get a job in which it's cognitively stimulating. You can learn on the job. So opportunity begets opportunity. In the same way, lack of opportunity undermines the possibility of future opportunity. So if you have a very difficult neighborhood, unsafe, let's say, or if you have parents who aren't well educated and they're not going to be teaching you a lot of academic English, then you're going to be a little behind. And then if you're a little behind, things happen, and we know what happens, that you can fall into a lower track. You may not end up having many years of schooling, and you might end up in a job that isn't all that stimulating. So what I'm trying to say is that inequality is overdetermined because it's multi-contextual and it's cumulative. Okay, so if that's right, if very coherent forces in society create inequality, then it follows that our interventions must be equally coherent. So we need, therefore, it would seem, to push for contextual coherence. Let's get the adults in a child's life on the same page, working together to maximize the growth of that child's skills, early and continuing. Okay, contextual coherence. Cumulative coherence, let's take a life course perspective. And fancy word for that is, but it's a good one. It's a good term, Kuna and my colleague Jim Heckman, dynamic complementarity. What this means is when we make an investment early on, we create a foundation such that can be built upon by future investments. The next investment can build on and take advantage of the effects of the earlier one, so you won't have fade out, right? So you have kids in early school making big gains. What are we going to do in elementary school to capitalize on that and to even advance it instead of letting that gain fade out? That you can follow that logic through the life course. Okay, dynamic complementarity. One intervention later builds upon the successes of an earlier one. An earlier one is designed to be followed by a later one. And see, we can easily miss that when we do trials of individual interventions at different stages. How do they link together? That's what I'm trying to say. And that's, and in one way, that's the problem of practice, is how do you coherently combine what we learn from intervention? We need a theory. So here's the outline of the rest of this talk. I think what we need, and I'm going to argue, is a theory for how experience in school affects educational equality. And what I'm going to say is going to school reduces inequality when kids are little and increases it when they get older. That sounds kind of crazy, but I'm going to try to defend that idea, okay? I'm going to bring in the idea of a dynamic instructional regime. Kids are very heterogeneous. This is where Carol's work comes in. Kids are at every stage, they're heterogeneous in skill. We have to know what the skills are if we're going to advance them optimally through what I'm going to describe as a dynamic instructional regime, to summarize the kind of work that Carol and Fred have done. So we're grappling with skill heterogeneity, and we're being longitudinally coherent because we're building on earlier attempts to produce higher skills. We're learning from earlier interventions in order to make the later interventions more effective. Contextual coherent, getting the adults. In this case, I'm really going to focus strictly on the teacher and the parent. We could talk about more adults than that. I'm going to give an example from early math and then have some discussion. And in that discussion, I want to really emphasize this idea of tailoring, which the idea that kids are heterogeneous in skill. Tailoring means that they don't all need the same intervention. And a lot of people might think right away, well, you're just reintroducing tracking. No, we're not. I want to make a distinction between tailoring and tracking. They're really different. And then say a little bit maybe about an agenda for research. Okay. All right, so here's the theory part. And there's two propositions. Early in life, low-income children benefit more from going to school on average than do high-income children. Okay. And now I want to really, by the way, distinguish this from the kind of school effects research that a lot of us have been engaged in, launched really in some ways by the famous Coleman report of 1965, where school, and people say, well, Coleman said school effects aren't that important. He was talking about school differences and how much do they predict differences and how much kids learn. I'm going to be talking about school effects as the effect of literally going to school versus staying home. Okay, a little different. And that's going to be, we need to really think about that. And then the second proposition is that by adolescence, high income kids benefit more from a dose, let's say a year of schooling, than do low income kids. And the reason this is so important is because our interventions, if we do our dynamic instructional regimes well, can delay the crossover point, okay? If the crossover happens early in life, if the benefit of schooling, the disproportionate benefit that low-income kids get is reversed when kids are still young, you're going to end up with a lot of inequality. But if we operate sensibly, we can delay it. Ideally, we want to eliminate that crossover so that everybody would benefit. Okay, so let me try to defend or sort of explain at least what I mean. Why do I say this? I mentioned Coleman. So what I want to put forward is a counterfactual account of the impact of schooling. Very simple, but I think it works. So what is the causal effect of going to school? Let's define Q sub school as the quality of academic instruction that a child is going to get if they go to school. Whereas Q sub home is the quality of the academic instruction they're going to get if they stay home. For little kids, that might be right. For older kids, it might not be staying at home. It might be if they were not in school, if they were on the street, or if they were wherever they were going to be, okay? So each child has like I'm going to go to school or I'm not going to go to school. If I go to school, I'm going to experience a certain level of academic instruction, Q school. If I stay home, I'm still going to get academic instruction. It may be very informal, but parents are going to teach language. They're going to teach me how to think in certain ways. My friends, my peers. So the idea is that the impact, therefore, of going to school on instruction, this is specific to the child. Each specific child has Q school minus Q home. It's the difference between two counterfactual treatments, going to school or staying at home. All right? But we also have to think about what is the impact of instruction, whether it occurs at home or at school, on your skill. And it's going to be delta. And therefore, the impact of going to school on academic skill is going to be the difference between the quality of instruction you get at school versus home minus home, multiplied by the benefit of instruction. Okay, very simple model. It's kind of a simplification of the old Carroll model, really. And this is going to happen at each time T. I didn't put the T's in there, but basically it's for preschoolers. It's going to happen in elementary school. It's going to happen in middle school, high school, and beyond. Okay, so this, looking at it this way, we can see why school tends to equalize, particularly early in life, because although high SES kids get higher quality of instruction in school than low SES kids, and although high SES kids get higher quality of instruction at home because their parents have more education and they know more academic English and they teach, they sort of think about themselves as teachers more likely. So So high SES kids have higher Qs. But the difference between those is higher for low SES kids. See, this is the key point. The gap between the quality of instruction at school and home is bigger for low SES kids. And the reason is because the quality of instruction at home is much more variable and highly dependent on SES than the quality at school. Schools vary a lot less than homes do in their capacity of people to give academic instruction. Now, I'm not going to be one of these people who says that kids who are low SES have bad home life. I'm not saying that. Parents could be wonderful parents and very typically teach children how to be good people and how to care about other people and how to work hard and do the right thing. I'm talking about academic instruction, which you have a leg up if you've had yourself a lot of schooling, in the sense that you're teaching academic English. You're teaching the kind of stuff you learned in school. If you don't have an academic background, then you're not going to be giving your kid as much academic instruction. That's been established in a mountain of research. Okay, so this is really the irony. The high SES kids are getting better quality both places, but the low SES kids are getting a bigger bang for the buck by going to school versus staying at home, okay, in terms of the quality. However, in a way, school can disequalize, and here's why. The benefit instruction depends on prior skill, okay? That's sort of a fundamental assumption of this model. Like how much you're going to benefit from instruction depends on how much you already know. If I have a big vocabulary, I'm going to learn more from reading something than if I don't. Okay. The reason that you guys look at people's test scores and their grades and their skills when you decide who to have go to grad school is because you think they're going to benefit more from a year of your instruction that you're going to give than somebody who doesn't have skills. All right. Since the Qs are higher, both at home and school for the high SES kids, their skill is going to grow faster. Okay, so this is the dynamic. Okay. So on the one hand, the low SES kids are benefiting more from school in that the contrast in quality is higher for them. But as the skills diverge naturally, as you would expect them to, the benefit instruction is going to be, the deltas are going to go up faster. Skills are going to go up faster, the capacity to benefit from instruction. And so what's going to happen at some point is that the SES gaps in favor of delta are going to overwhelm the SES gaps favoring low SES kids, having to do with the quality of instruction. I hope that's clear. If anybody has a question, just shoot. By the way, I'm willing, not only am I willing, if you have a question, please ask it in the chat or have a comment. I come from a university where that's what we do. And if you don't do it, I'm going to feel very insecure because I don't know if anybody's actually following this. If you disagree with me, that would be a good thing. All right, so I think Jessica's going to monitor the chat. All right, so that's a theory. Is there any supporting evidence? Well, actually, Jessica mentioned the article that Robert Eshman and I wrote in the Annual Review of Sociology. We reviewed reviewed a number of articles showing that early on, school attendance reduces inequality, okay, very clearly. So, for example, we looked at a large number of interventions to create universal preschooling in 8 different countries, and virtually in every case, it was the low SES kids who benefited more from those programs. And these are pretty well-designed studies. They're natural experiments, but there's things like what Fred did, which is using regression discontinuity in age, looking at the kids who do and don't go to school. When this thing was introduced, it's really cool. You know, the universal pre-K is introduced, but you have to be a certain age to benefit from it. And then you can compare kids who are just around that age cut. And you can compare the kids around the same age cut point in the year pre-policy. You know, it's a very nice design. It's been used all over the world. It's very convincing. So providing universal pre-K The low SES kids benefit more in a bunch of different skill domains, including emotional learning, not to mention math and early early reading. By the way, in fact, in a lot of these countries, the high SES kids don't realize any benefit in their cognitive skills from going to preschool. If you think about it, the language environment, the richness of the linguistic environment at school might be not as high as it is for home from a very high SES kids, right? Because, preschool teachers they don't have a lot of education. But for low SES kids, there's a big advance. Okay. Lengthening the school day. We don't have as much evidence. We have some. One of my favorite studies, I think one of the more convincing ones, done by a former student of ours, Chloe Gibbs, half day versus full day kindergarten. Who benefits more? This is a randomized trial. It was the low SES kids who benefited more, particularly minority kids. Lengthening the school day doesn't always work, and we think it's probably there are other IES funded studies that show the same thing. It doesn't always work because what kids do after school isn't always very well connected or aligned with what they're doing during the school day. At least that's an explanation for it. Interrupting schooling with the summer recess. This is something that Barbara Hines started a long time ago looking at. Carl Alexander and Doris Entwistle, and then more recently, Doug Downey at Ohio State has made a career out of studying how much kids learn during the summer versus how much they learn at school. A wonderful natural experiment. And what we see, particularly in reading, not so much in math, but in reading, since as you know the story, right? The high SES kids, they stay pretty much stable over the summer. Maybe they learn a little bit, and the lower SES kids don't learn as much, and they even maybe fall back a little bit. They learn similar amounts during the school year, but they fall back during the summer. So if you think of how much you learn while you're in school versus how much you learn at home, twice annual observations, fall, spring, give you data on the school effect for each and every child. It's a beautiful natural experiment. And what we see is that the low SES kids benefit more from going to school. And we have some data on interrupting schooling with the summer recess. So so we can actually reverse that if we give good schooling during the summer, okay? Well, the second claim is that school attendance increases inequality later. So one series of studies, and I could say a lot, I don't want to dwell on this too much, but there are a number of interesting studies by Phil Oreopoulos and other investigators studying in nations where the compulsory school age was increased. So in Britain, for example, at some point back in the 50s, I believe it was, maybe the 40s or 50s, can't remember exactly. You could leave school when you're 15. They changed the law. You had to stay until you were 16. This has been done in many countries around the world, and so mostly economists have studied this. And what we see is the first chance we get to see how much the kids who would have dropped out learned while they were in school, and they learned something and it benefited them. But it's very clear from these studies, and Dick Murnane, whom all of you probably know, a wonderful educational economist, was one who alerted me to the fact that if you really look at these studies, the kids who would have dropped out a lot of them didn't gain much from staying at school. And on average, they certainly gained less than the kids who would have stayed on. So there's evidence that a year in school has a disequalizing effect. Kids benefit more from being in school because they have greater skill later on if they've had great instruction at home and in school. Okay? So that's the theory. And if that's the theory, I think I'm going to argue that it has big implications for a life course perspective on how we're going to reduce inequality. Because when we do effective early interventions, we can't just let the effects fade out, okay? And we can talk more about why that happens, but that's what we tend to see happening. We have to capitalize on those early interventions in order to make sure that the gains are sustained And that's where Carol's work is going to come in very handy. I'm going to talk in a minute about preschool interventions. We'll talk about how that can be connected with Carol's work. And I'm going to say something about some work in high school showing similarly that we can still intervene by expanding instructional time for kids who are a little behind. It has a big effect. So if we put these things together across the life course, I'm not saying we'd eliminate the gaps, but we can delay the point in life course at which the high SES kids start surging ahead more than the low SES kids. So the term I'm going to use here is I'm going to use this idea of a dynamic instruction treatment. Okay, let's start with the dynamic treatment regime. My former colleague at Michigan, now at Harvard, Susan Murphy, has written the sort of I would say the seminal mathematical piece on this. So a dynamic treatment regime is one in which it's a set of rules for assigning treatments given assessments. So she worked a lot on behavioral therapy or drug therapy, kids who are having behavior problems. You assess the kids, you assign an intervention, you watch to see how well they do, you reassess, you tailor, and you do this over time. And a regime is a set of rules for assigning treatments given the assessments. It's given that the child is at this level and has this history, what's the optimal thing to do next? And the idea is to optimize this regime, if you take it very formally, to optimize it to get the best outcome, to build a regime that has optimal decision rules through a method called backwards induction. Interestingly, you start at the end and you say what's optimal, and then you will build backwards. And that's very formal. It's a very tough article to read. It's in the Journal of the Royal Statistical Society, but it sort of maps the way practitioners think. This is what doctors do. You go into the office, they check you out and look at your cholesterol. They look, right, and they decide whether you needed more statins or something, right? So let's think about schooling as a dynamic instructional regime, okay? So in this paper I introduced this idea in 2008. I said that teaching is a continuous interplay of assessment and instruction. An effective teacher is ever attentive to the current level of student skill. The interplay is dynamic. The appropriate next step in teaching a skill is predicated on the observable success in having taught the prior step. And that's just virtually a statement of how teachers operate. It's not necessarily very formalized. And I think that we can benefit from formalizing this more because we're getting so much better at collecting real-time information and using it. And we can help teachers be more effective in doing this and build teaching as a part of building the teaching as a profession through making this a little bit more formal. So again, we're going to use this idea of a set of rules for assigning instruction to children based on a sequence of rigorous assessments. It's not a new idea. I'm going to say something about response to instruction a little bit later. There's a lot of people who've been thinking about this idea. But I do want to say that actually the teacher's job in some ways is more difficult than that of the physician who's thinking about the optimal treatment regime, because the teacher has to think about collectively a whole bunch of kids who are being assessed and who vary in their skill, and the treatments have to be administered in some kind of simultaneous situation. Very, very difficult. Whereas, at least the physician has one person coming in at a time, and what's that person's record and how are we going to do this? So how you organize the classroom, this is something Carol was masterful, Carol and Fred, how you organize the classroom to make the tailoring possible when you have this multiplicity of trajectories, if you will, okay? So the idea would be to look at it, to sort of expand the idea of a regime so that it's not just on, let's say, early reading, or it's not just on early math, or it's not just on high school algebra, but to where it has a life course perspective. how do we build on what kids learned in preschool when they're in kindergarten or first grade so that the gains don't fade? So it's a cumulative way of thinking. And contextually, how about engaging the parent as a partner? Here's where your child is, and we'll say something more about this in a minute. Here's where your child is. What's the optimal? Here's what we're working on to get your child to the next step. Partnership. Parents know, and they know exactly what to do to help out. Okay, that's kind of the model. So the example I'm going to give you is just published in PNAS. My colleagues, Susan Golden Meadow and Susan Levine are really fantastic developmental psychologists who do very basic research on learning. And through their study of children from age 1 up until age 15, intensively following a small sample of children, about 60 kids over many years, and videotaping them and looking at the language that they're exposed to. That was really the basic science foundation of this study. Longitudinally adaptive assessment and instruction, and we're looking at early math. Okay, so here's the basis of this. It's something we call the 60-20 gap in math achievement. And so what I'm saying, so 0 is going to be at fall of kindergarten. The kids who are in the blue line are the kids who are eligible for free and reduced lunch. They're in the ECLS 98. They're at about the 20 to 25th percentile of the distribution of early math. And the kids, the green line are kids who are not eligible. So these are the, I won't call them high SES. We can call them high SES, but which means that they're just not eligible for free and reduced lunch. They're at about the 55th to 60th. So we call it the 60-20 gap. And when kids enter high school from ECLS, that gap is virtually identical in percentile terms. It's a parallel set of curves. Now, how these curves wouldn't necessarily be parallel if you change the scale of the outcome. But when you look at percentiles, it's virtually invariant, stunning. And when you go to the ECLS K 2011, which we followed only up to 6th grade, but we see virtually identical results. Okay? So this goal of this study was to eliminate or to dramatically reduce the gap that kids would bring with them. And so the propositions behind this are that the gaps arise from input differences at home and school. And that's where the foundational work of Susan Levine and Susan Golden Meadow came in. That the key skills that constitute this gap can be defined, measured, and taught. In other words, it's not something that you're born with some wonderful, I'm a math person, so I'm going to be really good at math. Some kids take to it maybe faster than others, but the component skills that constitute this gap, we firmly believe can be just regular, normally developing kids will benefit if they get the right input. But that means teachers need to know what the skills are. And I didn't know what they were. I mean, maybe the teachers know, but people say the teachers already know, but preschool teachers, I don't think have been taught what those key skills are. I didn't know what they were. A lot of people, until I met the two Susans. Anyway, we need to know what the skills are, the level of skills of each child, what is the next step, what are the interactions, tailoring those, and how to check child progress. So the idea is that teachers assess each child individually. They plan interactions tailored to the skills, reassess 10 weeks later. Very similar to what Fred and Carol have been doing in reading. And also they've done it they've done with one article that I saw in math. Check progress, revise the plan, and iterate 3 rounds per year. So the study, just to give you a sense, 49 classrooms, 88 teachers, 350 kids. So we matched the classrooms in terms of blocks to make them as similar as possible within schools or centers. We randomly assigned those classrooms within those blocks. Classic sort of, I guess, Jessica, right? This is a multi-site cluster randomized trial. You had kids in classrooms in centers, and it's the classrooms that are assigned at random. And we get about a 0.29 standard deviation gain in numerical skills, which is about 45% of the gap that I showed you, the preschool entry gap. We didn't get a gain on spatial skills. I can comment on that. We might want to discuss that. We have some explanations, some possible reasons. And we also got a gain in verbal comprehension, which is very interesting. We have some ideas about, we thought this might happen. There's some earlier research when kids, there's a lot of vocabulary in math. It's a lot of logical vocabulary. It builds comprehension. We can talk about that. This plot shows that the gains really were experienced by the little kids. This is the age of the child. These are not growth curves. This is the age of the child at post-test on the horizontal axis and the numerical reasoning on the vertical axis. And so the red are the experimental and then the blue are the control kids. And what we see is that the biggest gains were for the littlest, the youngest kids and for the oldest kids. And we think, we like to think, and we sort of suspect that the teachers have learned how to tailor better, that if you pitch the instruction to the kids in the middle who are around 4.5, which is kind of the typical age in these classrooms, those kids, there's not much effect there. But because the kids who are behind are not really getting what they need, and the kids who are ahead, because of their age, literally, are not getting what they need. We think that's what's going on. That's more of I could say a speculation or a conjecture, but it's an interesting one. The input gap that really generated this project was the idea that we have what Susan Levine and Susan Golden Meadow found was just vast variation in literally the number of number words children were exposed to during the first, second, third, and fourth years of life at home. Tremendous differences. And they classified these number words. Some number words aren't very meaningful. It's just, 1, 2, 3, I'm throwing you up and down. Sometimes, now you've got 3 marbles. That's a numerically meaningful thing. They study this stuff. And the kids who have more exposure, controlling for lots of other stuff, to number words, learn more. And they even, Susan Levine even extended this to the preschool classroom. In preschool classrooms where there are more number words, this sounds crazy, the kids are learning math better. They're having more exposure, more input. So that was the idea, is that it really is rooted in early experience. But we want to, and it's linked to SES, get kind of really specific about, well, what are those skills? So what we did was we took the ECLS, the Woodcock-Johnson, we did a big field test. We took a test that's very similar to what ECLS kids got, but we then measured a number of component skills, and we looked at the kids who were at the 60th and 20th percentile on the global sort of math, numerical side. And we said, well, where are they on counting? And counting here is a little bit sophisticated. It's not just counting up to 10, it's actually sophisticated counting, like counting backwards. And it's kind of like a continuum of skill. Where are they on cardinality? Cardinality is knowing the size, understanding what the size of a set, understanding that if I count 1, 2, 3, 4, that it's a set of size 4. That I have to be able to count 1 to 1 to do that, right? There's sort of an ordering of this stuff. If I know cardinality and I can order size. I can flawlessly rank order sets with respect to how large they are, and I can begin to look at operations. If I added 1 to this set, how many would I have? I don't have. If I add 1 to a set of 4, I don't have to start 0, 1, 2, 3, 4, 5. I can say I had 4. I've got 1 more, and now I have 6. And of course, there's another side of written numerals, which is really not that key when they're little, but it becomes important to have a symbolic representation of these sets. Okay, so that's kind of the domain. And so we did this field test. As I said, we equated the skills to the ECLS skills. And we used that then to set targets. We said, if you're going to be at the 60th percentile for OK, then you need to be at this percentile in counting. You need to be at this percentile in cardinality, et cetera. Backing it down and kind of extrapolating down to the earlier ages. So that's what this says. So, for example, see if I can see my title here. Yeah, for numerical thinking, this is for the domain as a whole. See, this is kind of the gap. If you guys can see my cursor, I hope you can see it. The green line is the is the higher SES kids. The blue line is the lower SES kids. That's the gap that you see as a beginning point of ECLS. But based on our field test, we extrapolate that works backwards because we see this quadratic growth curve with respect to this, and we backtrack these percentiles. So we see that, if you want to be where the rich kids or the high SES kids, not really rich, the higher SES kids are at the end, here's where you need to be at 3.5, at 4, 4.5, and 5. We need to bring you up. We need to push your trajectory up. For cardinality, which basically all kids get, just about all normally developing kids will get the idea of cardinality, but some get it earlier than others. And that means if they get it earlier than others, that means they're comparing ordering sets earlier, they're doing operations earlier. So it's a big foundational sort of a gate that you have to go through to get to the next level. And here's what we think the trajectories are for the high, extrapolating back from ECLS using our field test. Operations is a more sophisticated construct. Okay, I think you get the point. We set these targets. So one of the biggest problems is limited assessment. This is something people don't want to, spend too much time on assessment. Although what we learned is that when teachers are assessing their children individually on these very specific skills, they're learning an enormous amount about not only what kids know, but what they need to teach and what the skills actually are. So we think that the assessments play a very big role. At any time t, we're going to have a good estimate of the child's current skill. We'll revise our estimate of their entire trajectory. We'll assess the impact of current instruction because we can look back and see where they were last time, and we'll predict where they're going to be in the future. And the reason that's important is because the assessment is adaptive, meaning we have to choose the items that are at the level that are correct. This is so important for little kids. If you give a little kid who's, let's say, a young child who doesn't have who's just starting out, you give them a lot of hard items, they're just going to get everything wrong. It's not a nice thing to do to children. But if you give a child who's a little more advanced just a whole bunch of set of items, they get everything right, you don't learn anything. So we need an adaptive assessment. And we especially need it to be adaptive because assessment time is limited. We have to get a very efficient estimate. I want to show you how that works. We're actually going to select a new assessment booklet next time we assess you. It's not quite like the computerized adaptive testing. Same idea, but it's a little rougher than that. Okay, so because there's limited assessment time, there's limited information in any one assessment, we have to have a way of accumulating knowledge in order for this to work. And we're going to use a Bayesian learning model. We're going to have at time 1, all we really know about you is your age. And we're going to give age appropriate assessment. And we're going to collect some data. And at time 2, well, now we know not only your age, but we know how well you did at time 1. And we're going to select an age appropriate booklet. We're going to collect some more data. And we're going to re-estimate your trajectory based on more information. All the information, what we learned in time 1 and time 2 is going to be the prior for time 3. Then we're going to get new information. We're going to know your age, the data from time 1 to time 2, select a skill appropriate booklet, collect some more data. Each time, of course, the teacher sees the data and figures out what to teach. So here's the test information curves. I have to get a little technical, right? I'm supposed to be a methodologist. I got to give you some of this stuff, right? All right, I got to keep my trade going here. So the booklet A is the easiest booklet. It has a lot of information for lower skill, numerical skill kids. When they cross over, then suddenly the second assessment becomes the optimal one. We learn more, and then it's where they cross over, you change booklets. Okay, so that's anybody who knows IRT, that's kind of what you do. I want to show you why it's so important to be Bayesian about this. This gets into the weeds a little bit, but it's kind of interesting. So the dotted line here is the average trajectory of this counting skill. Remember, counting here is conceived to be a pretty hard skill because it includes not only counting to high levels, but counting backwards and being able to count from a certain number on. And so it's much more flexible thinking about numbers. So it's kind of a gently positive quadratic. It's mostly linear, but it's slightly quadratic. So that's what we know. So when you hear the ages of the children, we don't have any information. It's kind of where we expect you to be. All we know is your age. We expect you to be there. So we give an assessment, and we decide that this one child is here. And we say, well, that's where we think the kid is based on the assessment. But actually, we know there's error in the assessment, so we're going to use a Bayes estimate. It's actually going to be shrunken a little bit toward the predicted value. Why? Because there's an unreliability thing going on here. All right. Okay, so then we're going to assess you again, and you didn't do very well. You're down here. We're getting more evidence that maybe you're a little below. But you made but our belief is that you're making some gains. That's what we see because we're combining information about age with what your assessments were. Oh my God, this kid shot way up. You probably don't totally believe that. The test, remember, there's not much time. There's not that many items. So it's not as accurate as we hoped. Well, Bayes says, well, let's put the kid here because we're using all the information to get the best possible prediction of where the child is. The child is actually here. We're starting to see the child is maybe growing a little faster than expected. And then, bad day for the child, or, the Bayes says, okay, well, let's not overdo how bad we think it is. There's a trajectory. Child shoots up. This is kind of an extreme example, but I think it illustrates the idea. The Bayes puts you here, and this goes on. And so the solid line is kind of our best estimate. And so we actually think that looking at all the data, this child is actually moving slowly away, a little better than expected, a little bit faster trajectory, starting off pretty similar starting point. So we get this kind of picture of the child, a better picture. And if we're able to continue this, of course, the longer we continue, the more assessments we do, the more information we get. So you need to do this. And here's kind of the figure on the left is if we just went with the individual assessments, they're all jumping up and down. But if we go with the best estimate, we see this kind of trajectory. So that's why we need to use some prior information to get a better picture of where the child is, so that we don't want to jump around and make extraordinarily ridiculously variable instructional decisions. We say, well, my God, this child's going to go into like advanced calculus, and this child's next time they do really badly. We're not going to do that. Okay. Here's what the teachers, there's a bunch of things we show the teachers, but just to give you a sense. Did I show you? Let's see. No, never mind. Okay. So here's the child counting skill. This child is actually somewhere in kind of knows, counts to 10, maybe not counts up hot, all the way up to 29. Maybe this is the beginning of the assessment, the first assessment. And the length of this line, here's the little kid, and here the length of this line is a 90% confidence interval for where we think that kid is. So the teachers would see this, and then they would see maybe after several assessments, they, by the way, if we didn't use Bayes, they'd see what's on the right. But if we did use Bayes, they'd see what's on the left. And you can see that it's associated with where the child is with certain kinds of skills. And then we brainstorm with the teachers, but we have some ideas already about what kind of instruction would be appropriate for somebody who is at one of these skill levels. Okay, so I think you kind of get the idea. So that's the idea of that study. That's the idea the teachers really are kind of very interested in seeing how this plays out. They want to become experts at this. This is what makes, this is really going to make them professionals, but in a good way, because it's going to enable them to think more systematically about each child and how to do the instruction. I didn't say anything about parents. Hey, we're supposed to be contextually coherent. We didn't really have anything in this study. I do in the Ambitious Elementary School. That's the book that Jessica mentioned. There's a similar regime, sort of a very much of a Morrison, Connor/Morrison regime on reading, especially, but also math. I call it Bright Greenberg Knowles ILIF because my dear friend and longtime collaborator and former advisor, actually, Tony Bright, working with his wife, Sharon Greenberg, they really developed this approach within a couple of elementary schools on the south side of Chicago. Elizabeth Hasrick and Lisa Rosen and I wrote a book about this, which is mostly a book about this model, this school as an instructional model using what really is a dynamic treatment instruction regime, we were able to capitalize on a randomized lottery so that we can actually get good causal effects. We want to be in the IES spirit, right? Showing the dramatic gains that these kids made. I mentioned Tim Knowles, who ran the set of 4 schools that the University of Chicago runs on the South Side. And I mentioned Nicole Iliev because she was the exceptionally capable principal who really knew how to make this instructional regime work on a school-wide basis. So what I want to say here, the reason that parents are relevant, because what they did was they said, okay, this child is at this level of reading or math. Here's what we're working on to get you to the next level. And then they got the parents involved and they said, here's what you can do at home. I want you to help us get this kid up to the next level. The parents like this. First of all, they're being respected as partners. Second of all, they're being given something specific to do. And if it's math, it's something that they might not thought they were very good at, but if they know exactly what they have to do, they gain confidence, self-efficacy that they can actually do it. The first question I always get when I talk about this is, well, a lot of parents don't care. They don't have time. They're having kinds of emotional problems. Okay, let's think about this response to intervention. Okay, remember that idea? I'm going to talk about that a little later. Lynn Fuchs and Sharon Vaughn and others. The idea, it works here. So the idea is you try to get every parent involved. The ones that all get in, most of them respond. They get involved. The ones that don't, okay, now we have to take extraordinary measures. Nicole Iliev would say, we have to wrap a family around that child because we don't have a person at home who can really do this. And that does happen. But we'd never know who those people are unless we did the outreach to all the parents, right? Okay. So really, I'm coming to the end of this. I think we'll have some time for discussion. So will the results fade? This is what we see in so many early childhood interventions, particularly of the preschool math. We're worried about this. And our reviewers for PNAS, one of whom was Greg Duncan. By the way, in PNAS, the reviewers are known. So it's not, in fact, he published and printed on the paper who did the reviews. And Greg, we knew about the literature reviews he and Drew Bailey had done showing that the fade out of these things. But they have a theory, and it's very similar to ours, which is what happens is the low-income kids who benefit from a terrific early intervention go into kindergarten, and they tend to go into kindergarten with a whole bunch of other low-income kids, most of whom didn't benefit from the intervention. The kindergarten teacher sees all these kids, uses standard whole group instruction, and pegs the instruction at the level of the median or maybe a little lower. And so the kids who learned all this stuff and got way ahead, they don't benefit. And Amy Claessens, who's at Wisconsin, has done some really interesting work with ECLS showing that a lot of kids are sitting in classrooms being taught stuff they already know. Because people are very worried about the low-income kids, okay? And the lowest, not just the low-income, but the lowest skill kids. By the way, there's plenty of low-income kids that are high skill, right? But those high-skill, low-income kids are not necessarily getting the opportunity because people are deeply concerned about the low-skill, low-income kids, and they should be. But that shows you why we have to be more sensitive to the heterogeneity. We've got to have a better way of coping with the heterogeneity. And that's what this dynamic treatment regime idea is, and that's what Carol and Fred have pushed. And so the idea would be to use let's take the stuff that Carol and Fred did and give it to the kids who we had in our early school so that they can see those kids are going to get under Carol and Fred's model, they're going to get the optimal instruction because they're going to know where those kids are. See, this is kind of the ideal. So we've got to prevent fade out. I mentioned the ambitious elementary school. One thing that we know from that book is the kids, after they left elementary school, their effects when they went into the middle school did not fade. And we discuss why we think that's true in the book. Partly it had to do with picking the right school for them. One thing that happened in that school was that there was a tremendous attention to selecting the optimal middle school for each and every one of the kids who were graduating. Some of the kids would go to an exam school, some in Chicago. Some of them would go to this kind of a magnet school, or they would go to this school. It's a neighborhood school that's very good at is a good match for this kid. And that's a regime-like thing to do, right? To optimally assign people. And I think that combined with the fact that they had a skill, benefit of their skill, plus they were optimally assigned, or at least, pushing toward optimality for their middle school, that helped those kids. And we don't see fade out. In fact, we see that, if anything, the skill gains of the experimental group, the kids who went to these schools, actually increases. I want to mention another paper that I've been working on with, we've just published, actually it's coming out in PNAS with Taka Konomi and Jake Smith on double dose algebra. You've probably been following this. This is funded by IES, thankfully for that. And we knew that double dose algebra increased learning of math and increased high school graduation, but we followed these kids now all the way from ninth grade all the way through and beyond college, and we're seeing effects on college persistence and degree attainment, even four-year degree attainment. What happens in ninth grade algebra? So what happens is, it's a very rough kind of a regime, very, very coarse, but still effective. Give every kid a test. Kids who are below the median, give them 2 periods of math, where one period is designed to sort of fill in the gaps that you need to fill in order for them to benefit from the other period, which is an academic algebra class. So they take academic algebra, but it's supplemented. And now we see from Loeb, Douglas, Watanabe et al., we see this happening in community college with very powerful effects. You know, it's been a bad story. Remedial math in community college has not been pretty. But with this double dose approach, with the supplementary classroom, we're seeing similar effects. And all of this, of course, is related, as I mentioned, to research on response to instruction. I mentioned Lynn Fuchs and Vaughn and others, where you try to do the best possible tier 1 or optimal instruction, and then it enables you to discover who are the kids who are not benefiting. It's using intervention as a form of assessment and tailoring then in the sense of making sure that those kids who really need more resources and more intensive intervention get it. It's really building that principle in. That principle has been used more in special ed, but it's something that we can use much more broadly. So those are the basic ideas. I do want to finally just say that sometimes when I talk about the tailoring, that, you know, grouping or tailoring kids according to what their skills are, this is something that Carol and Fred did. Okay, we're gonna. If you need code-focused instruction, you're gonna get it in a teacher-centered classroom. If you're ready for meaning-focused and you're doing reading to learn, you know, we're gonna put you in a more child-directed situation. And well, it's grouping, and isn't that tracking? And my answer is no. And the reason is, it has to do with the purpose tracking used to have and the purpose we have now for tailoring and differentiating. So I have this quote from Sorokin. I love this quote. 1959, at the present moment, it is certain that the school, while being a training and educational institution, is at the same time a piece of social machinery which tests the abilities of individuals, sifts them, selects them, and decides their prospective social position. That's tracking. That's tracking where this is what I had when I was growing up. You were put in a track at the 9th grade that was determining where you were going to be as an adult. The purpose of it was to differentiate your life position, your social position as an adult. That's not what we're doing with tailoring. We're trying to push the entire distribution up. But in order to do that, in order to do that effectively, you've got to make the instruction relevant to the current skill levels of the kids. And it's a dynamic process. Then the kids benefit, then they move on. And then, you know, and maybe they're good at one thing, but not something else. And you've got to make sure that, you know, that kids are getting the instruction they need. This really, I have really come down against the idea that every school and every classroom should be completely heterogeneous. I don't think it achieves the goal of reducing inequality. And what do we mean by inequality? Well, I don't mean that everybody's going to end up being the same. And what it means to me is that if every child learns to read with high levels of comprehension, can write and express their ideas speaking articulately, and can reason with data and think mathematically in a reasonable way, then no one is excluded from discourse about ideas and policies and what should happen. Everybody's at the table. That's equality. It doesn't mean everybody is the same. Some kid might be 12 years old and doing the 4th year calculus, and somebody might be reading Dostoevsky when they're 13 or something. Kids will thrive at whatever they thrive at, but nobody's being excluded because they don't have the skill. Okay, nobody's being excluded from participation, from discourse, and that's a very high level of a minimum that would create a kind of equity, or maybe equality isn't the right word. And the other thing about it is that whatever differences there are in skill, they're not linked to the circumstances of your birth. Thank you very much.
Jessica Spybrook is with us on the phone right now because she lost her internet. So she is going to try to ask questions. And if it doesn't work, I will take over.
Okay.
Okay, it doesn't work. So we're going to start with Karen's question. Have you thought about extending your model to multiple aspects of identity, for example, intersectionality approach, incorporating race, gender, ELL status?
Okay, great question. So in the book, and I won't be claimed to be an expert on this, by the way. We need to team up and figure this out. I wouldn't claim to be the person who's going to give the very best answer, but I will say this. In the ambitious elementary school, these schools that the University of Chicago runs are all African-American schools, about 85% low income. And I might say it, not because people like me favor, segregated schools, but we live on the south side of Chicago. Okay, it's an extraordinarily segregated city. One of the points we make in the book, the motivational, the reading materials, the kinds of discourse that kids are engaged in, is so important for motivating kids, and so that's another form of tailoring. It doesn't mean that we don't want African Americans to read Dickens. Maybe we do because Dickens was tough, but we want them. They can compare what was happening to poor people in England, the discrimination and the class society, with what's happening, with something that's very compelling in their own circumstance. So culturally relevant pedagogy becomes very important. The substance of what people study is tremendously motivating to the extent to which they can be engaged. So I think that in that sense, and I don't know, maybe that, Karen, I'm not sure that really captures, maybe you can tell me if that's really getting at your question. That's kind of my first blush response.
Okay, Karen, if you want to follow up, please put that in the chat. We have one that came in through our Q&A. Could you say more about targeting strategies to avoid tracking that can avoid tracking? Tracking usually starts out as targeting, but it rarely ends up that way because when individuals are sorted for targeting needs, they also end up sorting on other grounds. As you know, I see a lot of value in your stance, but it's been hard to accomplish.
Right. Yeah, no, I think it's a really good point. So the dynamic kind of assignment and the assessment creates opportunities, especially if you combine it with, if kids get extra time. I think that's really crucial. If you're behind it, let's say you're doing fine in certain domains or certain skills, but you're behind in something. Part of the story is you got to have more instructional time. So this is part of this RTI idea. Is that, the double dose algebra, right? Or the idea, in fact, one of the key things in the ambitious elementary school, when Nicole Ilieff, here's an example, when she saw that in one of the two schools, the one where she was the principal, the kids were coming in third grade, were so far behind in reading, she expanded instructional time in reading 3 hours. She went from less than 1 hour to 3 hours. She completely reorganized the school. She reorganized the time. She put the best teachers teaching reading to those kids. And this was a lot of the kids, not all of them. And so those kids ended up being really good readers. Okay, in our results, if you take a look, you'll see how much they gained. Well, now they don't have that problem. It's really bad for a kid to be in 6th, 7th, and 8th grade not knowing how to read. We can't let that happen. And there's no reason to let it happen. And that's one place we can rely on research. Every child, about 95% of the kids who are exposed to what we know how to do in reading instruction early will become good early, competent, at least early readers. And the ones who don't get that, we'll know who they are. And we know that those kids need some intensive work. They need 80 hours in a classroom of size 2 with an extremely highly trained person. And we know that works, okay? So I'm being very optimistic here. But I think the data bear me out. So we want to make sure that we get these skill levels where they need to be, because it's the perpetuation of low skill by our system, if you want to look at it that way, that's going to cause the stigma, and that's going to cause the inequality and prevent people from staying in school and getting good jobs. So really the skills have to be brought up. Instructional time becomes a crucial resource for that.
Okay, thank you. We have a question that I think is particularly pertinent in the middle of our pandemic. How does EdTech fit this? The idea of dynamic instruction is something EdTech seems to be selling. Is this a reasonable direction, or is this about teaching?
Well, I think that it is certainly a great opportunity for technology to be better than it is now, meaning that you can tailor. The machine can keep track of kids' skill levels and can ask questions or create problems or text to read that are tailored to, that are going to, by the way, tailoring means that you're always being challenged, right? The zone of proximal development. You're always being challenged to go to a higher level, but not so high that it's completely ridiculous and is dispiriting. So, but the problem is that we don't have a lot of evidence yet that we know how to use technology in classrooms. And sadly to say, that if you look at Bob Slavin's work, synthesizing research on lots and lots of interventions, the technological innovation research is not inspiring at this point. So I don't think we've learned how to use this. It's really interesting. Back in the old days, like when I started out in third world countries, there was something called distance education. It wasn't on the computer, it was on the radio, or it was on TV, a little later on TV. There was a highly skilled person because there weren't enough skilled people locally. And there were many experiments. And what we learned was that if you have a really good plan for facilitating, processing what was coming through the radio or the TV in this group setting, collectively, face-to-face, that then you could benefit from the instructional level. And I think maybe we haven't learned that yet. We haven't learned how to do that in our classrooms and how to do it at home. I mean, come on. There's no way that this instructional model can do anything but increase inequality. You might not believe this. I've got 3 adult children and 7 grandchildren, but I'm a widower who got remarried. And I've got a 12-year-old kid. So I've been one of these parents at home dealing with online education. And let me tell you, it's home learning. It's homeschooling. The parent is the key person who's got to be active. And so it just goes back to the inequality of homes. I mean, the sooner we get through this, the better. That's all I can say. Yeah, it's been heroic. People have done a heroic job to try to mobilize education. The city of Chicago tried to create connectivity with almost every kid in the city. They gave out computers to every side. A lot of kids didn't have computers. At the beginning of this thing, tens of thousands of kids just simply disappeared from the system. We're not talking about reducing inequality with this model. We're talking about just trying to stop from drowning, okay? That's my view. I don't know how you all feel about it. I'm sure we're learning stuff. I know what we'll be able to learn. Some of the stuff we're learning now can be put to use, but I don't think we really know how to use it yet.
Okay, thank you. The next question, can you discuss the process and what it takes to get from interim assessments to change in teacher practice differentiated instruction?
Right. That is the hardest problem, is how do you really manage this? In preschool classrooms, there's usually 2 teachers, at least, sometimes 3, for a modest number of children. And there's, in the typical US preschool, there's a lot of kids doing different things in the room and a lot of incidental opportunities for teaching math. I mean, you don't teach little kids math by sitting them in rows and giving them pencil and paper and asking them to solve problems. I mean, it's working with manipulatives, playing with dolls and trucks and marbles, and you got so many opportunities for counting and comparing. I mean, there's so many ways to teach math through everyday interaction, and that's what they need to learn. When it comes to beyond that level, when you get into the elementary, there's more and more work on grouping, and I would really defer to some of the experts, maybe some people in the audience. I don't want to push this aside, but that's the kind of stuff that Carol Connor and Fred Morrison really worked on, is how do you give information to teachers such that they can use it to appropriately differentiate. They made a big distinction between within early reading on code versus meaning focused, and teacher versus student centered, and trying to move kids along so that they could move, master that early reading and move in. Not that not that there's no meaning but a lot of early reading is trying to decode familiar text, right? It's a lot it's not necessarily new ideas. It's mapping the what in your verbal vocabulary to the printed word. So the reading experts have some ideas about how to do this. I would defer to them. It's less often done in math. More math is, as far as I see, again, from what I'm learning from the math experts, is whole class. I think there's more people are learning better how to do this, but I wouldn't be I don't declare myself to the expert particularly. I think in the preschool, we could see how it happened in our study. And in high school, it was literally assigning an extra class. That was what it was. That was the key. More time.
Okay. Going back to our first question about building in some different variables, is the model different for poor girls versus poor boys?
I don't think so. I don't think there's any evidence for that.
Okay.
And there's, we didn't see gender differences. We don't usually see gender differences in math. If we do, they slightly favor girls early on. If somebody has a great hypothesis, then we should try it. But I haven't seen the evidence for that.
Okay. How does this type of work fit into the usual IES efficacy effectiveness grant study system? It seems more focused on heterogeneity, for example.
Yeah, but Carol was focused on heterogeneity, but Carol was a champion when it came to doing large-scale randomized trials productively. In the early part of the IES, I think a lot of us were a little discouraged. A lot of the interventions weren't really having an effect. But when Carol and Fred got involved, and some others, and really did some creative work using randomized trials, so using the IAS paradigm, certainly the preschool math example I gave is a standard IAS randomized clinical trial, within which is the iteratively assessing and teaching, keeping track of every child, keeping very close track, and trying to push everybody toward a higher trajectory. What we could do, what I would love to see us do, would be to do a randomized trial that bridges preschool and elementary, so that we very self-consciously seek to eliminate fade out and sustain those early gains. That could be done within the IES paradigm. The people that I'm working with on this project are piloting what they call vertical coherence, which is, having the work that the preschool teachers do with the K-5 teachers, making it coherent, so they know each other is doing. They're using common assessments. They have a plan for how you advance the skills. We haven't seen much of that, but it could be done within the framework of IES.
In our comments, we have Liz Albro from Department of Ed is noting that Carol's work was supported through efficacy studies at IES.
Right, exactly. So that's exactly what I'm agreeing absolutely with.
Yeah. So here's a big question. Let me find it again. If you were going to build the system knowing what we know from scratch based on current evidence, what would this change?
Well, that's a big question. I think a lot of things would change. One of the things we talk about in our book is that the way we design leadership and school organization should be driven by how we understand the work of teaching. And the work of teaching, presumably, it should be driven by how we understand learning. And so it's a bottom-up view. And it's kind of the idea of a school as an instructional system in which kids are learning and teachers are learning how to enact these so-called regimes, or how to appropriately teach kids who vary in skill. And the school as an organization is really very different. It requires a lot more collaboration, a lot more sharing of data. If there's a lot of uncertainty about how you do your work, Brian Rowan has written about this. When you have a school, when your conception of teaching involves expertise, uncertainty, variety in what you do, you have a very different organization of the school than when you think of the job of teaching as being highly routinized and predictable. It looks more like a factory, like an assembly line or something. So the whole organizational system, and then, like I say, the parents, if you want to get the parents, okay, so here's one innovation that happened in the book. A person who would normally be the vice principal, often in charge of discipline, became the director of family and community engagement. Todd Barnett, I don't mind praising Todd, was the one who did this. And Todd was the one who really sought out and engaged the parents. He had a plan every morning when the people were bringing their kids to school, which parents he was going to talk to and what he was going to say about where those children were and what they were trying to accomplish and try to engage and keep that child going. Well, that's a different kind of school than what we usually see. The social work was different. The social workers were much more integrated with the teachers. They were part of the team. It wasn't just, okay, well, I don't want this kid in my classroom. Let's put him over here and put them in special ed, and then the social worker will take care of it. It was a different kind of model. So I think the school as an organization has to function very differently to make this work.
Okay, we have one last question before we end here. The last question is, I was intrigued by the non-computer assisted adaptive assessment used in studies you discussed. You're saying the adaptation was valuable even on a time scale of months rather than milliseconds. If so, isn't this a promising technology despite the use of test booklets rather than tablet computers?
Yeah, so a lot of people ask, why didn't we computerize this? And this is really something that I'm a methodology person who gets a chance to collaborate with brilliant people and learn stuff from them. That's fun. What they showed me was that the math learning involves manipulatives. It involves stuff. I mean, the assessment involves playing with materials. It's not just it's not clear they're not absolutely convinced that at the early ages that you can do this. I know the computers are getting better and smaller and smaller kids are learning how to respond, but there's still a role for interaction with stuff. And it's because of that we couldn't do, because the assessments involved, there's boxes of games and stuff the kids have to play in order to do the assessments. And so that still seems to be very useful. So we haven't quite gone to the computerized version of assessment yet.
Okay. Steve, I know that everyone can't clap out loud for you, but they're clapping at home or in their offices where they are. And thank you so much for being here today. A year after we were supposed to see you last year in Arlington, for your flexibility and rescheduling. I know that there are probably other questions. As I said, people like to come up to the stage afterwards, and that's what we're going to hopefully do now in our Zoom networking session. So bravo.
Thank you very much. It's been really wonderful to have this opportunity.